Hi everyone, and thanks for that warm welcome. Great to be back here at NGDE, great to see you again. And also great to see you in the video. Our next talk is about building desktop class productivity apps with Angular and Project Fugu. And so as you can see, there's many stuff in there, so I think it's best to just show you what that means. And therefore, I've built a little demo, and the cool thing is that all of you can try that out right now, using your device that you have in your pocket or on the table right in front of you. So just go to paint.js.org. This is a web-based clone of the old Paint, Microsoft Paint for Windows 95 that I used to use a lot back when I was a kid. And this is entirely web-based. And the cool thing is, it allows you to draw something. So it's a productivity application. And it's like, it's the same thing as if it would be like a word processor, right? Word or Excel or a code editor, doesn't really matter. So this is just one example for a productivity app. In that case, we can draw images. Lots of tools and actions are implemented. It's installable. You can add it to your system. You can read and save files from into the file system. You can copy and paste images from into the clipboard. You can share files to other apps. And you can even register for file extensions. And all of that is possible with the help of Project Fugu. But first of all, let's have a look at the demo. All right, so here I'm just opening that application. So basically, I'm just entering like the address of the application in the URL bar. And then you should see this screen here. The idea for progressive web apps is always that you can just use the application right in your browser. So without needing to install it or to do anything else, it just works in your browser. I've implemented some tools, like the fill tool, for example, or the brush. Not all tools are implemented yet, so if you have any spare time, then all of that is open source, so feel free to contribute. So as you can see, it does its job pretty well. But now we want to take it to the next level, because I really like this app and I want to use it more often. So what I can do is install this application. Installing is supported in Chrome and in Edge and other Chromium-based browsers. And it's as simple as clicking the install button here in the address bar, and then confirming this prompt and saying install. What happens now is that that browser tab that you've just seen opens now in a standalone window. And on mobile operating systems, it will open in a full screen view. And now it looks as if it would be a native application. So for example, here in the system menu, you can see the name Paint and not Microsoft Edge anymore from where I installed it from. Here in the dock, I have the application now, which I can also move to my frequently used programs. And also in the app switcher, it now appears as if it would be a native application. That's number one. Number two is that this application now also is super fast because it uses a service worker and a copy of the application is kept offline. So if I close this application here, and maybe if I even just kill my network connectivity here, kill the Wi-Fi, and I click the application again, it will instantly open. So no loading anymore, no contacting server, no loading assets, it's directly there. No delays whatsoever. That's the second part, an application that now is offline capable and is installable to your system. And now the third part is provided by Project Fugu, which is also in the title of this presentation. And this wants to even further improve the experience of applications on your operating system by providing even better and even deeper native integrations. So let's have a look at that. First of all, I need to restore my nice drawing that we just had. So add the sun again. Very nice. Perfect. All right. Now I want to save this drawing to my local file system. And doing so is simple. I can just go to the File menu here and select the Save As option. And now the native File Save dialog will show, and I can enter a file name for it. So let's say foobar, or NGDE, as we are here. And now in the Finder app, you can see that this file was now created, and it contains my drawing. So the canvas is a little bit bigger. That's why the file is so big. That is nothing new. You could do that before. But what is new is that you can now also change and modify this existing file, choose to save it, and now this file here will be overwritten. That is something that was not possible before. enabled by Project Fugu. You can also read the file back in by selecting the open method or open menu entry. Then you can also select a portion of the image and use the copy command. And then, for example, I can switch to the preview app provided by Mac and paste it here. And what it does is it now opens a new preview document from the portion of the image I selected in the browser. Not possible before, enabled as a part of Project Fugu with the async clipboard API. And this also works the other way around. So if I add something here, like add another bird, select this, copy it, and paste it back to the application again, then I receive the portion of the image that I selected in the preview app. Perfect. So that is accessing the clipboard. Then you can share this drawing by using the Web Share API, using the send command, and here then the native share sheet comes up, and I can share this drawing to anyone who uses AirDrop. Let's see if there are some people with AirDrop in the room. Sometimes they are. Currently, doesn't look like it. Okay, too bad. But you could now also share this drawing to like any person that has AirDrop or using another application. Also, this application has access to the local fonts table. So if I open this here, yes, I can see like the entire list of installed fonts on my system. Really important for painting applications like this one here. And also, when I installed this application, it registered as a file editor for PNG files. So when I close the drawing here, and let's remember how it looked before, so that was the last saved state. And when I now right-click the image here and open the Open With menu, then I will find my PWA again. And when I click this, shows a permission dialog, which is fine, and then I can open it. And then the app opens again and shows the file that I had selected in Finder in that case, or in Explorer. That is basically the objective of Project Fugu, an even better integration for web applications in the operating system. And the cool thing is that this not only works on desktop platforms, which I will mainly focus on today, but also on mobile platforms. So if you tried it out on iOS or Android, it will work more or less the same, and you can do more or less the same stuff with it. All right. So as a part of this presentation, I want to show you how you can re-implement some of the things that you've just seen in Angular applications. And so there's basically 4 steps to it. The first step is that you need to build a great application. So the Paint demo that you have just seen, it runs great in the browser. And I basically used the Canvas API for that, right? The Canvas element and the 2D rendering context to draw on this on the canvas. And that is something that is like not surprising at all. You can do this for, I don't know, I think over a decade now. So nothing really new. So all browsers, all evergreen browsers out there, including IE, by the way, support the canvas element and support a 2D rendering context. And so the first tip for you is that you should always write applications that run just fine in the browser. Because how you distribute and how you deploy those apps is a detail, actually. So it can be packaged in an Electron app, for example, or in a Cordova app, capacitor app, or you can just distribute it using the normal way, using the browser. So again, always build great apps that just work fine in the browser. I prepared this here already. So basically, I've created a new Angular workspace, and what basically looks pretty standard, I would say. Also, I was super lazy. It only has like the app component where all of that happens now. So let's have a look how that currently looks. We can run ngserve here. Wait for it to compile. And then I can open it here, localhost 4200. That's basically the Angular-based version now, right, from the repository that you have just seen. It's more or less the same thing, just a stripped-down version, but you can still like draw something, you can select a different color, and all of that is working just fine. And now, over the course of this presentation, I want to add offline capability and installability. and then introduce the new APIs that you have seen, async clipboard API and file system access API, to make the buttons here at the top working, because currently they don't do anything. All right, so let's have a look at the different levels. The first one is the PWA level. PWA is short for Progressive Web Apps, and it's a web-based application model. That term was coined in, I believe, 2014 or 15, so that's also like year number 7 or 6 maybe for Progressive Web Apps. So again, nothing really new. Progressive Web Apps is also an umbrella term. It is like representative for category of applications. And basically in the initial blog post that lined out how Progressive Web Apps should work, and also in the discussion afterwards, basically 10 different characteristics were found what actually makes a PWA. So for example, apps should be responsive, should adapt to the screen size, should be linkable, you can copy and paste links to the app, should be discoverable, we can distinguish them from normal websites, should be installable to the home screen or to the dock, as you have just seen, should be app-like, so look and feel as if they were a built-in application, should be connectivity independent, so also run when the when your network connection is bad. Still, despite the offline cache, they should also be fresh, so as up-to-date as possible. Should be safe, transported via HTTPS, re-engageable, capable of sending push notifications to the browser, and progressive. That means they should not exclude users from older or less powerful browsers. That's the idea. So the thing is, you won't find a PWA specification anywhere, so no technical spec that reads Progressive Web App, but instead it really is a set of characteristics that an application must or should support. There are 2 technical specifications now, though, that are the foundation for this application model for PWAs. Both are maintained at W3C, and the first of it is the Web App Manifest that contains defines the appearance and behavior of an installed application on the system. And the second one is a service worker that is capable of keeping your app offline. It has a cache on its side, which you can use to store all of your assets locally on the user system. You can also do more stuff like sending push notifications and so on. Fortunately, to add PWA support, again, that's mostly for offline capability and installability. This is super easy to do in Angular. It's only exactly one command that you have to execute, and that is called ngAdd @angular/pwa. So we want to do that next. All right, so I switch back to our application here. I stop ngserve, and then we add add @angular/pwa. Yeah, okay, I should go back online, of course. But you can see it worked. So offline capability seems to work. Okay, now let's hope that I can connect again. Would be nice. JS party. Okay. All right. So let's add or run this schematic. What it does is now it adds those 2 things to my application. So first of all, it adds a web app manifest. Again, appearance and behavior of the installed app, and it enables service worker generation for production builds. So here we can now find the web app manifest. It's just a JSON-based file, and for example, I can change or update the name here. Want the name to be paint, NGDE, and I can also specify a short name that is used on mobile operating systems, because in a programs list, you have much space on a desktop system, but on a mobile operating system, you don't have as many. On the home screen, for example, you only have a couple of characters there. So we are going to use this. All right, and then service worker generation has been enabled. So what we need to do in order to try that out is to build the application by saying ng-build. This is a productive build now, so Angular will now automatically add the service worker to it. And if I go to the output directory, which is Paint Workshop, I believe, and I then run a local web server here, then here my application opens again. So same application as before, but now it is installable and offline capable. So we can do the same thing now. If I click the button here, install paint NGDE, right? This is what I just entered, and I confirm that, this application will now open in its own standalone window. And the system menu updates, and it appears in the app switcher, and it appears in the dock, and so on and so forth. Also, it is offline capable, so let me pin it again and close it, and just kill the local web server. It will continue to run, and it will load instantly. And that is the second level, offline capability and installability. As I've said, PWA is also like almost old now, so it's been some years now. So browser support actually looks quite good. Offline availability provided by the service worker is supported on all evergreen browsers. Installability is supported everywhere with the Chromium-based browsers. Currently only on the mobile systems for Safari. I could imagine that this changes though. So I could imagine that also on the desktop we can sometime in the future maybe install apps. It's different for Firefox though. It's only supported on mobile, that is Android, and there are no plans to implement installability for the desktop. Also, just as a little side note here, push notifications are supported by Chromium-based browsers in Firefox, and push support is now finally also coming to the Apple platform with Safari 16 on macOS Ventura, and next year, 2023, for iOS and iPadOS, which is really great, I think. All right, and now we come to the third level here. And the third level now has to do with this thing here. This is a pufferfish or blowfish, it's called. And in Japanese, it's fugu. Fugu is a very famous Japanese dish because the fugu is poisonous. So when you eat it, it's like a very interesting taste and experience because it makes your tongue feel a little bit dizzy. But if it's prepared wrong, then you could potentially die from it. So Project Fugu is a code name that actually fits quite well. So on the one hand, we as web developers, we need modern APIs and many capabilities to compete with native technology. So we need file system access, and we need clipboard access. But on the other hand, we need to make sure that basically authors of malicious sites cannot just piggyback on us, right? And create some very bad experiences here. So that's why that code name actually makes sense. Project Fugu is an effort within the Chromium project. And like the main contributors here are Google, Intel, and Microsoft, plus others, also Samsung Internet and others and individuals. And the goal of this project is to even further close the gap between built-in applications and web apps by introducing new APIs, new powerful capabilities to the web platform, and consequently reducing the need for wrapper approaches like Electron, Capacitor, Cordova, and so on. That's the idea. And the goal always is, as you can see here with this mascot of this project, to keep or to maintain the user's privacy and security, although we now enable and unlock more and more experiences for web developers like you and me, of course. Here we can see the Fugu API tracker. If you're interested, have a look at it. This is a dashboard that shows the long, long list of APIs that Project Fugu has already introduced and plans to introduce. Here on that slide, for example, you can see the Web Bluetooth and Web USB API. You can directly talk to Bluetooth and USB devices from within your browser. Super interesting. And this list is like super, super long. So there will be lots to talk about in the future thanks to this initiative. Again, if you're interested, have a look here at the API tracker. The cool thing for us now as web developers is that Fugu APIs are super easy to use and super straightforward. we use progressive web apps and Angular for cross-platform development. And we did other stuff before, where we had to write stuff like if-dev Windows, and if-dev macOS, and if-dev mobile, and something else. Those days are gone with the web platform and the Fugu APIs. Here, you can see the so-called web share API. What it does is it opens this little share sheet that you've seen before in the Paint demo. And all you need to do basically is call one method, navigator.share. And then your browser, on compile time of the browser, so to say, combines this JavaScript method with the actual native API. So Firefox on Android, for example, will call the share intent. And Edge on Windows calls Data Transfer Manager API. And Safari on macOS calls MS Sharing Service Picker. You don't have to deal with this anymore, which is good, by the way. It's now the browsers that have to deal with that. And you get a very simple and easy-to-use API. All right. Now I want to show you some APIs that are interesting for productivity applications. Again, text editors, image editors, code editors, video editors, and so on. And the first one that comes to mind here is the File System Access API. So many applications use this traditional file-based workflow, right? You open a file, you change it, you save it back. You double-click it in the browser, and it opens again in your application. That's the idea. And the File System Access API allows us to do exactly this, to open files, save them, overwrite them, and even open directories and change their contents. It's currently only supported by Chromium-based browsers since version 86, and that's already like 3 years old, so for the last 3 years we already have this API here. And again, the APIs are always super straightforward. So that is the show open file picker API, for example. You can see you can add some more info there, right, and some config. You can say I want to open more than one file, for example, and I only want to be able to open PNG files. So let's go and add this to our application. So I quickly switch back to WebStorm here and to the app component. And now maybe we first want to save a file. And to do so, we first need a blob. So basically, we need to convert the pixel data to a PNG. And therefore, I've created a helper function called toBlob. Then I need to pass like the reference to the canvas element to it. Yeah, forget look away from the exclamation mark. I'm lazy again. All right. Now we need to get a file handle, and that's also quite simple. All we need to do is await window show save file picker. Again, we could add some options here. I'm skipping them. All right. Then we can create a writable. That is basically a file stream writer. So if you did native development, all of that should look really familiar to you now. And then we want to write the contents, so the blob, and then we want to close off the file, writable close. All right. I'm going back to npm start now because it's a little bit faster to show, thanks to hot reloading. All right, so now we should be able to save the drawing here. Let me check. Save, perfect. The native dialog comes up, foobar.png this time, and let's check if it worked. Here we have the file, and it contains my awesome drawing. So it's working. Perfect. Opening is also comparatively simple. This time, we need to use the show open file picker method. It could open more than one file. In theory, the default is that it does not do it. Still, we get an array, and I'm only interested in the first file in that array. And then we need the image from this now. We first need a file. So I need to say handle get file. This now contains the binary image data. And now we need to convert that to pixel data again by calling the helper method get image for file. And then we can draw this image on our canvas. So this context, draw image, image 0, 0. And so by saying that, going back to the browser, I should be able to now open and read back the file again. And it works. Perfect. All right. Now, accessing the clipboard works pretty much the same. We have a new API here called the async clipboard API, which, as the name says, allows reading from and writing to the clipboard in an asynchronous manner. May require user consent first. And the API is, again, super straightforward. Write and read on navigator.clipboard. So let's also go ahead and implement this in our application. Right, so here we go to copy. And the thing is, it's now pretty much the same. So I can just copy the blob generation method, and now we call navigator.clipboard.write. That takes an array. Then we create a new clipboard item here. Say the name is image PNG. Oh, sorry, made a mistake here. Actually, this promise needs to go, whoops, that needs to go into the object here. So I need that actually, whoops, to go in there. And that's it. Now we should be able to copy things. Yeah, we can await that, of course. So let me check. Here, we copy it, go back to the preview app, and paste it, and that's my drawing again. Now, pasting it back is comparatively simple. Just want to show the code here, because as you've seen, there's an array, and you can have multiple items. So basically, you have to do a little, like a double for loop to get all the to search through all the items, but it really is more or less the same thing. All right. That is the async clipboard API. So clipboard access is also perfectly possible. And the third one is the file handling API. With the help of this, you can register your PWA for certain file extensions, for example, for PNG files, as the Paint demo did. All right. And this, of course, requires installing the application first, because we need like a representation of the app. We need the icon, we need the name. And that's why this API is an extension to two parts. One, for the web app application manifest. We just need to add this new entry here and say for which media types and for which extensions we want to be opened as an editor. And then there's this imperative code here. So let's also go and try adding this to our app. So we go to the manifest, and again, super lazy, so I just go back to the presentation here and just copy that. File handlers. So we want to be called for PNG files, so we say image PNG. PNG. We could even specify an icon if we want. And then the imperative code uses the so-called launch queue. And so we also will add that simply here to my NGDE method. Okay, actually that should work. Don't know why it does not right now. So let's see if that's fine. Actually, it does not look too happy here. Again, being lazy. Oh, all right, okay. No, it seems a little bit broken now. Let me see if I can fix it. All right. Perfect, looks good. So let's switch back to the file, call the light server again. Then we can see if it did actually work. So, also, I need to reinstall it. That's important now because the manifest changed. So by saying uninstall and going back to localhost 3000 and hopefully installing it again. Okay, currently it doesn't show up. No. Oh, yeah, could be. Sorry, then I broke it, but actually it looks fine. But basically, yeah, correct. This one is, I think this was too much. All right, but I think the concept should be clear. That's the way how you can register for file extensions, as you've seen before in the initial demo. All right, browser support, async clipboard API everywhere except on Firefox. They only support write text. File system access only supported on desktop Chromium. Not so positive signs from the Safari and Firefox side, so don't expect it to be implemented there in the near future. And then progressive enhancement says that you should always keep in mind that there are browsers that do not support a certain API. Fortunately, this is super easy to implement. So all you do is use an if statement, check if an API is actually present, for example, the show, say, file picker. And if it's not, then you can simply fall back to an alternative API, or if there's no alternative API, you can disable or hide the functionality entirely. Now the question is, who uses that stuff already? The thing is, many people do. For example, Microsoft published Visual Studio Code, web-based version of VS Code, super simple, as VS Code is web-based anyway. Use the File System Access API, and you can edit, update, override files on your local file system. Really cool, you should try it. Photoshop has released a web-based application. Adobe has released a web version of Photoshop last year, entirely web-based, really cool, try it out. We even have numbers for that. I was a part of the content team of the Web Almanac 2022 capabilities chapter. Last year, async clipboard was used on 9% of all desktop websites. Now it's 10%. File System Access API was used on 29 desktop websites. This year, it's over 2,000. So basically an 8-fold increase over last year. Also, if you're interested in that stuff, have a look. All right. So to quickly summarize this, Project Fugu is pretty awesome as it brings new APIs to us, and that unlocks new app experiences on the web. And as Angular allows us to write great web applications, this is a perfect match. So Angular loves Project Fugu, and Project Fugu loves Angular. And so basically, all that I want to say at the end is, yeah, let's go build great applications, enrich them with Fugu capabilities, and make the web more capable. Thank you very much.